These notes are going to go over domain and range of functions. So let's start by talking about the difference between a relation and a function. A relation is simply a set of ordered pairs, while a function is a special type of relation where every element in the domain has only one pair from the range, meaning every x value has a unique y value. The domain and range, which you should be familiar with, is the domain is a set of all x coordinates, and the range is the y coordinates. When we talk about relations and functions, we can represent them in several different ways, including a mapping diagram, where the values from the domain are mapped with their specific value in the range. They can be graphed either as points or as a line, and then an equation, as well as just the set of ordered pairs. Some key concepts to remember in this lesson are written here. Remember that a function maps elements from the domain to the range, and for every x that's in the domain, it can be mapped with only one y. If it's not, or if it's mapped, with more than one y, then it is not a function. So when we look through these to determine whether or not they are functions, we would look, is every x paired with a unique y? And that's true in all cases except for this one, because negative 3 is paired with both 0 and 6. So this one is not a function, while both of these are a function. This one is a relation, though, because it's just a set of ordered pairs. This one asks me if it's a function and then to state the domain and range. This one is a function because every x is paired with a different y. And to state the domain and range, for this one, this is a discrete function. We'll talk more about that later. But I would list all of my x values here in my domain, and I would use these little braces. So listing them in order from least to greatest. My least, or my smallest x value, is negative 4, then negative 1, 0, 2, and 3. And my y values make up my range, starting from least to greatest. Negative 4, negative 3, negative 2, and then 3. 3, even though it occurs twice, I only need to list it once in my range. And then here for my set of ordered pairs, this one is not a function because negative 2 is paired with the values of 2 and 4. To list my domain and range, it would be similar to the previous one. I would pick out all of my x values, starting with the smallest, and then range, same thing. So my range would be 0, sorry, I'm not quite sure what just happened there. My range would be 0, 0, let's see, 2, 3, 4, is that right? And again, 4 is repeated, as well as negative 2 repeated in the domain, but I don't need to repeat it when I list them. Determining whether or not they are functions. So go through and decide which of these you believe are functions, which are not, and then pause it while you do that, and then come back and check your answers. Alright, both of these first two are functions. Every x is paired with a different y. So here, all of them are paired with negative 6, but none of my x's repeat. Here, -1 is paired with 2. It's paired with 15, and it's paired with 0. And that would make this one not a function. And then this one is actually neither a function or a relation. Well, this one's not a function, but it is a relation. This one is neither because 16 is not paired with anything. And remember that the definition of a relation is a set of ordered pairs. Alright, same thing, I can go through and determine whether or not it's a function. I'm not going to state the domain and range for these because these should be fairly straightforward. All of my x values make up my domain, and then going back, all of my y values make up my range. But in this case, 2 is paired with -3 and 2 is paired with +3. So this is not a function, but it is a relation. And this one, if you look at the x values, this one is a function. Stone pen. This one is a function. Sorry about my pen malfunctions. Alright, when we're given a graph, the easiest way to determine whether or not it represents a function is to use the vertical line test. So in this case, if I draw a vertical line and sort of sweep it across, and it doesn't pass my graph or intersect my graph more than once, then it would represent a function. If it hits it more than once, then it doesn't. And if you think about it, let's say that this x value is 2. This would be 2, maybe 2 comma 3, and this would be 2 comma -3. So the same x value more than once is going to make that fail the vertical line test. Alright, so go through these and determine whether or not it is, and then we'll talk about the domain and range. So go ahead and decide function or not function. Based on the vertical line test, each of these graphs passes the vertical line test, so they are all functions. We talk about the domain and range for these. They're a little bit trickier. The domain, and we can assume, sorry, that these have arrows on the end. We can assume that that these go on infinitely based on these arrows. For my domain, remember my domain is all possible x values. So when I look to the left and to the right, I want to list it from least to greatest. So my graph continues to go to the left forever, which would be -infinity. Gracious. So my domain for this one is going to be from -infinity all the way to the left. And then as I go to the right, the furthest it goes to the right is this value right here, which looks to be about 1.5. Now we have to decide what to put around them, either a parenthesis or a bracket. And parentheses mean that it does not include that value, meaning it gets close to but doesn't not equal that value. And that's why negative and positive infinity always get parentheses, because my graph can approach or get close to -infinity, but can never actually reach -infinity and stop there. So we use in parentheses. When a graph comes to an actual value and it stops at that specific value and includes that value, then we would use a bracket. For my range, forgot about my range. Range is all possible y values. So as this goes to the left, it's also going down forever. So down forever would be -infinity. And the highest it goes is 0, y equals 0 on my graph. For b, my linear function, I have a domain. This goes all the way to the left all the way to the right, so domain is going to be negative infinity to positive infinity. And my range would be all the way down and all the way up, so again, negative infinity to positive infinity. Linear functions, as long as they are not horizontal or vertical lines, are always going to have domain and range that are both negative to positive infinity. And the last one is a quadratic that's been reflected. My domain would be all possible x values. So as this upside down u goes down, it also continues to get wider and wider, which means this is going all the way to the left and all the way to the right, which would be negative to positive infinity. My range would be the lowest to the highest, and the lowest this graph goes is going to be all the way down, because these arrows, to negative infinity, but the highest it gets is 4. So 4 would be included. Discrete versus continuous. If I have a graph that is simply a set of points, that would be discrete. If I have a graph that is a smooth line or curve, that would be continuous. Basically, discrete means I would have to pick up my pencil in order to draw this graph, whereas continuous, I could draw it without picking up my pencil. Using a mapping diagram, we're just going to do one of these examples and then state the domain and range. For mapping diagram, you actually separate it into domain and range, and you could represent this with y or f of x. But remember that I list all the values in my domain, and then I would list also all the values in my range, which are, let's see, 4, 1, Alright, so my range is 4, 1, 0, 9, and then I can map them. Negative 2 is paired with 4, negative 1 is paired with 1, 0 with 0, 1 also with 1, 2 also with 4, and 3 is paired with 9. Sorry, this should be a 3. Alright, this one does represent a function. And to state my domain and range, remember that I'm just going to list it as points, and I've already separated it out into domain and range when I mapped it. In order, remember, from least to greatest. I could do the same thing with this one. This one is not a function, however, because the x value of 1 is paired with more than one y value, as is the x value of 4. Using the vertical line test, remember, if I draw a vertical line, not quite a vertical line, but vertical line, and it passes through my graph more than once, then it would fail. So this one is not a function, but rather just a relation. Whereas this one, doesn't matter where I draw my vertical line, it's only going to pass through once, and therefore it's not going to pass, or it is going to pass the vertical line test. It's going to be a function. When I look at this graph, I want to go ahead and talk about the domain and range of this. My domain would be from all the way to the left to all the way to the right, so negative to positive infinity. But my range on this one, the lowest my graph goes is 1. Remember that we talked about what an asymptote is? And an asymptote is that line that my graph gets really close to but never actually touches. And that's what this is. So gets close to 1 but never touches it, which means we're going to use a parenthesis, not a bracket, because a bracket would mean it touched 1. And then the highest it goes is infinity. Allison decided to take a yoga class, and the yoga studio costs $10 to join, and then each yoga class is $5. So here's the function that represents this. It asks what's the domain and range. Well, if you look at this function, you should be able to tell that it's a linear function and that it's not horizontal or vertical, which, if you recall, we just talked about this. That means that the domain and range are both going to be negative to positive infinity. This is similar to the one we just talked about a minute ago. My domain for this is negative to positive infinity, all the way to the left, all the way to the right. But my range on this one is 0 to infinity, but it doesn't include the value of 0 because it's an asymptote that it just gets close to but never actually touches. If I look at a table and I'm trying to determine which function it represents, or represents the table values, all I have to do is plug in my x's to determine which one works. When I plug in 0, neither of these work, but both of these do. So I have to plug in 1 to determine which one gives me a value of 3. This is going to be the one that gives me a value of 3. This will give me a value of 4. So this is the one that works. Stating the domain and range, here is my domain, and here is my range. All I have to do is list them out.